If you spend time around advanced manufacturing, you've been promised that machine learning was about to transform the factory floor. A decade later, most of these promises quietly died. My guest today has a sharp explanation for why. Matt Gordon is the founder and CEO of A3 Analytics. He was an early forward deployed engineer at Palantir and spent 4 years at Toyota Research Institute. And he's finishing a book called Data-driven Kaizen. I first came across Matt when I was digging into the forward deployed engineering model for Format, and he turned out to be one of the sharpest thinkers I talked to. So I thought, why not have him on the podcast? Matt, welcome.
It's nice to be here. I think if we're being pedantic, I think we first met back at a previous job when you were working at Other Lab.
That's right. That's
right.
right.
I do remember many years ago, actually.
I do remember that part too, for sure.
Yeah.
Then when I was looking into Palantir, you came back around. But no, but I remember you from my other lab place very well.
Yeah.
Toyota Research Institute, Gil Pratt, the rest of it. So welcome, Matt. Walk me through the arc. Princeton Physics, early Palantir FDE, 4 years to Toyota Research. Walk me through the arc. Princeton Physics, early at Palantir, 4 years at Toyota Research, and now founding A3. Talk us through your career narrative.
Yeah, I mean, I started life as a physicist. I always loved physics when I was a kid. I kind of wasn't sure whether I wanted to be a computer scientist or a physicist. And so I kind of went back and forth. I think a thing that happened throughout my career is that I would switch around a lot because I have a short attention span and I'm always looking for a new problem. And so I spent a while studying physics. In my undergrad at Princeton, I was very interested in biological physics. I built a lot of experiments. I loved hardware. I moved on and I actually worked for a startup in Chicago called Geodesic Systems for a while. We were doing memory management software in the era before Java. So it was for C and C++. So I got a real taste for software engineering at that point, but I kind of got bored with that. I moved on. I went to University of Illinois to do my doctorate in biological physics. And I really loved, again, sort of the hardware and the facing the physics of these problems. And I eventually went to Stanford to do biological physics. And after about 4 years of that, I got really bored. And I jumped across the street to Palantir, which was at that point about a 230-person company. And that really opened my eyes to the problems of very large organizations and how they manage knowledge and data. And I got to do a lot of really interesting work across the government and private sector and the nonprofit. I think probably the most interesting work I did was in mortgage-backed security fraud, where we worked with the Department of Justice Civil Division to organize sort of millions of emails and spreadsheets that they were analyzing. And there was a huge recovery, I think about a $6 billion recovery from the banks that they were working with. After that, I sort of floated around the valley for a little while doing some stuff. I worked at a methane mitigation company, which was very physically motivated. We were doing hyperspectral imaging, so it was very well suited for my background in physics. I was doing back-end software engineering there. I really wanted to learn more about the art and craft of software engineering. And I eventually found myself, again, sort of at the end of a point where I was like, okay, I think I understand this process and this company. And I had sort of maxed out my equity and decided I wanted to do something else. And I found this job at Toyota Research Institute in battery manufacturing. And it allowed me the opportunity to study manufacturing at Toyota, which I think was the greatest manufacturing organization in the world by some accounts. They invented the Toyota production system, lean manufacturing. And so after I spent a ton of time there studying the data analytics and how sort of companies use that, I discovered that there were really very few guiding principles. It was very ad hoc. And at the same time, AI was starting to prove its worth as a knowledge management approach. And there were a lot of really great tools available to sort of cut through the noise of these very large amounts of data and knowledge, documents that were floating around and the conversations that were happening on Teams and things. So you could combine these tools to create very new ways for people who are not subject matter experts to access data, to plot data, to ask questions of knowledge, put those all together. And we experimented with a little bit of it at Toyota, but eventually I realized that Toyota was never going to be the place to sort of build a brand new sort of transformational AI capability. I needed to go someplace a little bit faster moving. And so I sort of broke out of containment and I started A3 Analytics to try and develop that concept into what I call automated root cause analysis. The idea that you can, using large reasoning models and multimodally, both knowledge within an organization and data, you can have a system that both can interpret a problem, propose a hypothesis, and test it using data and the available knowledge sources to try to speed up the rate at which people solve problems across many different manufacturing and hardware domains. And it gets me back doing something that I love, which is hardware and physics. Every one of these problems is its own physics problem. We studied spot welding at Toyota, incredibly interesting thermal and fluid mechanics problem. Stuff like that really
That's very cool.
me. So I really
So
love the
you
opportunity to work on these things.
so you have a long-term view of manufacturing, and when you and I talked before, you told me about how manufacturing essentially was told that machine learning was going to transform the factory. You saw that on the right predictive maintenance, digital twins, anomaly detections, and a lot of that stuff didn't quite live up to the promise. Like, what happened?
So I was sort of poking around for something else to do. And I tried starting my own company, and I shut that down within about 10 months. I discovered I didn't know how to figure out what product market fit was, but it was a good early experience for me in company building. I moved on from there to Kairos Aerospace, which then changed their name to Insight M. I was also working with Ari at that point, and I was a back-end developer then, and I was really building my back-end software chops. But this was a company that really got me very interested in climate tech. We were doing methane mitigation, and we were working with large oil and gas companies to try and help them rein in their methane emissions. You may be aware that methane is about 100x the carbon forcing of CO2. So it was relatively straightforward for us to actually have a huge climate impact. We had a bigger climate impact than Tesla in those years when you consider the rate of decarbonization of the electrical grid versus what we were doing with plugging these sort of very large, hard to find methane leaks. And I got very interested in the whole field. I started a nonprofit, Climate Tech Action Network. We do events in San Francisco. We've got a new event series coming up soon called Climate Tech Group Therapy, sort of capture the zeitgeist of the current feeling within that industry. I went from there after I had sort of fully vested, and I really felt after about 6 years of back-end software development, which I loved, I wound up developing the entire sort of back-end database for that, a lot of geospatial work with sensors. And again, it was kind of a knowledge management problem. You had these very large organizations, had all this geospatial data, and they had internal knowledge of where their assets were, but they didn't really know what to do with them. We were collecting sensor data. We had to sort of layer all that in ways that were useful to an organization so that they could go out and do quick mitigation of these leaks. And it was very physical. I sort of got to engage my physics brain again, and I really loved it. And when I was done with that, I was poking around for something new, and I found this opportunity through a friend at a Toyota Research Institute, where they were building a team to think about lithium-ion manufacturing and how to improve lithium-ion manufacturing. Now, this was an amazing opportunity to go work at what is arguably the world's greatest manufacturing company. They invented lean manufacturing in the form of the Toyota production system. And I went in there, the battery factory was still a hole in the ground. And so we started poking around for opportunities to learn about how does Toyota handle data? How does Toyota think about data-driven manufacturing, which is what everybody wanted to be able to do? And the answer was not very well. Almost nobody does it well. It is extremely difficult to do well. And I became fascinated with this question of, why is it so difficult to do? And the answers that came out from reading some of the literature were actually very surprising to me. I stumbled across an article that is now, I think, relatively well known by Telhelm at University of Chicago, and he described what he calls the rice theory of culture. And the rice theory of culture is that the means of production, in this case, rice farming, tends to, because it is very cooperative, because of the need of irrigation and the tight timelines for harvesting, requires cooperation across a whole village. So this tends to create very collectivist, cooperative societies. Whereas, on the other hand, wheat farming in America and in the Western world tends to be able to do with just rainfall and one family. And so his theory was that you could show, and he did this with, again, geospatial data and surveys and sort of various cognitive and psychometric surveys, that people who rice farm have a different set of values and they think about the world differently. They tend to think about the world holistically. They think about it in terms of the relationships and the complexity of those relationships. And people who grow up in countries that were typically associated with wheat farming, like the US, tend to think about things analytically from the bottom up. They think about individuals and their properties and how those things come together to form systems. And so those are actually very different modes of thinking about things. And there are cognitive and psychometric tests that show this. And when I read about this, it was like my brain exploded. And I went and I talked to a couple of my colleagues who'd been working in IT at Toyota for a really long time. And something I had noticed was that the people at Toyota were extremely collaborative. They cared a lot about the company and the product. They stuck around there for 20, 25 years. Being at Toyota for 15 years was considered a youngster. And I asked these guys, I said, do you think there are qualitatively different cultures between the IT group at Toyota and the manufacturing group at Toyota? And they said, absolutely, very different cultures. And this is why you often see, in my opinion, these organizations hate each other within large organizations. They do not work well together. They think on different timelines. They decision make in different ways. And the thesis of sort of a lot of the research that I did there was on this idea that actually this difference, holistic versus analytic thinking, is extremely important in understanding the friction at that interface. And that interface between data and physical processes mediated by people. You cannot ignore the people portion of this. It's what we call a socio-technical system. It's not just a technical system. It involves how people interact with it. And that makes a huge difference in how you approach these problems. And so I really started thinking about these problems in a very different way. And at the exact same time, we were thinking about these very large organizations, these manufacturing facilities that were handling very complex types of data and knowledge. They were handling large amounts of documents and technical manuals and things like that. And we were seeing huge problems with people just being able to find the things they wanted, get the data, plot it. People spending hours in Power BI. Nobody wants to use Power BI. People searching like the sixth SharePoint from the left to find the document that they were looking for in Japanese. And at this time, AI was starting to sort of really show what it could be used for. And in my opinion, there are a lot of really dumb things you can do with AI. And then there are a couple of really smart things you can do. And almost all of the smart things you can do with AI, treat it as a knowledge management tool. LLMs are a knowledge management tool. They are designed to basically do for documents what databases do for tabular data. They allow us to organize it and make API calls against it so that we can do things in a systematic way in which we are parallelizing. And so the basis of A3 is that my company was this observation that we have spent 10, 20 years looking only at the data, because that was all we knew how to do with computers, is really like look at the data using things like predictive analytics, where we would just basically take all the data, strip it of all its context, feed it into like a XGBoost and hope that something comes out. And really what was missing from that is the context. Walter Shewhart, who invented statistical process control in the said that data have no meaning outside of their context. And so what LLMs and large reasoning models, importantly, allow us to do is really look at a large corpus of knowledge that has been acquired by an organization over many, many years and mine that and use it to contextualize the data. So a really simple example of this is every time at Toyota, we would come across a piece of data that said, oh, at this time point, there was a change in the process variable of some sort. You would say, well, what was that? What happened there? And the very first question you always want to ask is, did somebody do maintenance? Because it's a socio-technical system. People are impinging on the system all the time. It's changing constantly. One of the hallmarks of holistic thought that people use in factories, they call it systems thinking in the Toyota production system, is this belief that things are never constant and that change is something that you always have to be aware of. And you have to be able to sort of get the latest information and the latest knowledge about what has been happening. Oftentimes that stuff is stored in conversations on Teams, in emails, in PowerPoints that somebody gave, in a maintenance management system like Maximo, where oftentimes the information is in the narrative field. And so being able to pull that stuff out and determine, yes, on this date, actually, maintenance did happen because we can see it in this maintenance log here, is an incredibly powerful new approach. So I call this a knowledge-driven approach to Kaizen rather than sort of a pure data-driven approach. It's a multimodal approach where we can use both the organization's knowledge resources in a scalable way and the data using tools like text to SQL to be able to take subject matter expertise and push it from the very highly skilled, highly paid people who've been there from 25 years and push it down and out so that the people at the point of production, at the Gemba, have access to that. So that at 3 a.m, if something goes down, instead of skimming a PDF to try and hope that there's an answer in there so that when your boss comes in, the system will be back up, you have the opportunity to ask questions in natural language and try to find that amongst the very large number of resources that might be available to you. And you can do that without a PhD. You can do that just by asking. Yeah, absolutely. I think actually many people know this now because if you've seen the sort of news reports that the forward deployed engineer job now has like 800-fold, sorry, 8 times the number of applicants, job postings as it did, some years ago. And the reason is we are trying to apply these systems to very complex systems like enterprises and manufacturing. And in those cases, these are socio-technical systems. We understand the way that people interact with them. We have to understand the way the data is being used, what the problems are. And there are very few solutions that you can kind of just toss over the wall. We worked with a text-to-SQL company who I won't name when I was at Toyota, and they really just wanted to toss the product over the wall to me. And I said, well, we're going to need this, 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 and this if it's going to work. And they said, we're a solutions company, not a consulting company. And I said, well, you're actually not either. You're not solving any of my problems. That sort of brings this full circle is that we discovered this is sort of with enterprise at Palantir. And in manufacturing, it's actually much harder because these are not just human systems, but they are physical systems. And the physics of the problem on the floor, really just being able to observe what's going on and seeing it is extraordinarily important for dealing with manufacturing. And so the story is that Taichi Ono, who invented Toyota Production System, used to bring people to the factory floor and he'd draw a circle and he'd say, stay here, I'll be back in 8 hours. In 8 hours, you'd come back and he'd say, what do you see? What did you observe? Like, what problems should we be fixing? The only way to get ground truth was to really be there and physically see it. And that's extraordinarily important, even more important than it was at Palantir.
I am so excited to dig into this idea that you were an early FD at Palantir in this model that's sometimes called software and services that is, I think was kind of made for something else in the early Palantir days, but is now seeming like a very promising business model in the age of AI, really. I'm curious about what you've learned in the early days there that you think a modern day founder or a manufacturing person could learn from.
I learned from the best, which is to say, Shyam Sankar really invented a lot of the ground rules of that role. And there was some required reading that I actually still require people to read when they come work for me. And so I can tell you some of those things. One of them was Crossing the Chasm, which you may or may not be familiar with. Classic. And it's about how to sort of get technology from prototype phase into these late adopters, right? And how to think about sort of how companies do technology adoption and what levers you have to pull to try and get through that sort of valley of death from like, okay, these people are like, small time operators who are willing to take risks. These are sort of the Toyotas of the world that are extremely risk averse. I think another really interesting choice that Shyam picked that we all read was a chapter of the book Impro about improvisation, and it's about status. And this is actually incredibly interesting and it was very influential on me. And what it describes is how in comedy, oftentimes people will portray different status roles in order to make comedy work. And what that means is that sometimes I am the rich person and you're the beggar, and that's a funny scene because you and I have different levels of power. Sometimes we're both powerful and we're fighting at it and we're both trying to see who's more powerful. In the context of business within a large organization, it is really interesting to think about and view these things through the lens of status. And this is one of the things that we learned from Shyam is that sometimes when you're going into a meeting, people want you to be an expert. They want expertise. They want you to come and play high status and say, I'm Dr. Matthew Gordon, PhD physicist, and I know how to solve your problems. They go, okay, that's really good. Sometimes when you're talking to people, they want to be high status. And your job is to go in and say, my God, you have been doing incredible work here. What is it that I could possibly do to help you? Here's the things that I can tell me about your problem. By manipulating sort of your approach to people, you can dig out one of the hardest parts of doing forward deployed engineering, which is what is the problem that we are trying to solve and what is the overlap of that problem with the technologies that we have in order to solve those problems. To do that, you really need to get inside people's heads because you face a very significant problem of self-reporting. People are terrible at self-reporting, right? And so I call this the man in the hole problem, which is you go to somebody and you say, hey, you're in a hole. Can I help you get out? What can I do? And they say, well, could you bring me some water and food? And you say, well, what if I throw you down a rope and help you get out of the hole? And they say, what do you mean? because they have not imagined a world outside the hole. And your job is to help them imagine a world outside the hole, but you can't just ask them, what do you want? So this is like, for
Right.
instance, the theme of the book, The Mom Test, in terms of like product development. The forward deployed engineer's job is to take this very general purpose platform. Palantir had one. OpenAI, for instance, has another general purpose platform, and do the last 20% product market fit. Figure out how you're going to fit this product to the market that you're going at, build the connectors and the data integration, and demonstrate the value to people so that they go, wow, this is amazing. This is transformative. This has completely changed me. I need all of it and more.
That was one of the beautiful things about the previous paradigms of software, right? That there was a one-size-fits-all model in so many ways. And then we went out there and tried and shoehorn the software that we were so proud of into problems out there, and often it wouldn't work. So Palantir became a proponent of this software and services model. But how do you strike that balance? How did FDEs feed back to the platform at Palantir? Because I imagine right now the barrier to and the cost of software development is plummeting right now, right?
Mm-hmm.
So we are sort of in this emerging long tail of software where people can really get a lot of custom stuff, but there's still room for not everybody. We don't want to all become consultants, essentially, right? We want to feed things upstream to the platform, things that are generalizable. How did you think about balancing those concerns at Palantir or today at A3?
Those are actually, I think, very different because they're very different situations. And
Mhm.
so at Palantir, there was always an interplay between the forward deployed engineer and the code that you wrote and what was on the back end that the software engineers wrote. And the fact of the matter was that the software engineers who worked at Palantir, famously, very brilliant people, and they were hired from the best of the best of the best, did not think very highly of the code that was written by the forward deployed engineers, right? So there was generally a very high bar to demonstrate that something that you would come up with was actually important enough that they would roll it into the product, as opposed to simply, there was like a list of plugins and tools that people had built that you could sort of like root around in, like, your grandma's attic and pull something out and be like, yeah, maybe I could reuse this. So that would happen occasionally with things like,
These think of the software people then.
well, I mean, I loved the software development team. They were all often very generous with their time. That if you came to them with questions, they would say, oh, absolutely. I got in trouble once because I filed a ticket and the support team was feeling very overwhelmed. And I walked out when I was having lunch, and I found the dev who had worked on this just in the stairwell. And I said, oh, actually, can you tell me the answer to this? And she said, absolutely, here's the answer. And I filed in the ticket. I found the answer from Danielle, and the support team came back and said, you can't go around us. You got to go us. And I said, but I ran into her in the stairway. Like, I'm sorry.
Yeah.
This is why we all work in the same building. We kind of forgot that post-COVID, but this kind of thing used to happen, right?
That's some startup energy to just
Yeah,
go
exactly.
and grab
It was
the
really good.
person.
It was fast. It was agile, right?
Exactly. Exactly.
So with A3, I have sort of a more strategic view. And the thing that I took away from Palantir that was really interesting was that when you have this general purpose platform, the last mile, that 20%, allows you to take a tool that was, for instance, built for intelligence analysis and deploy it to a bunch of different problems. And that allows you to scale horizontally. And that's how you build a $100 billion company, is by having a tool that can handle many different types of problems. And so on the one hand, we have the SaaS apocalypse, where all these companies are getting squeezed by the ability of sort of like anybody to write new software. But it tends to be pretty janky. And so if you need sort of like a well thought out, well designed system, that won't work. In manufacturing, you really need to think hard about how you're approaching the knowledge management, the ingestion and the data, and how people are going to use it. And so you can do certain limited things, a lot of things actually, with sort of Claude code, but to have a true general purpose system that solves a lot of your problems instead of solving just one problem, it needs to be well thought out and implemented at the point of use, at the Gemba, with respect to how people are using it. And so you have the SaaS apocalypse coming at you from one side, and then from the other side, you have the people who are saying, well, in 18 months, Claude is just going to sort of solve everything, and you'll just throw it all in there, and you won't have to worry about any of it. And I don't know a nice way to say this, but that's ridiculous. The tools themselves are limited in terms of what they can do and what they can't do. Context windows are scale sublinearly with memory. So, one of the reasons we're seeing $1 trillion outlays is simply that, like, we're now in a linear regime of AI, and software works best in an exponential regime where sort of the amount that you can do is exponential with the amount of compute that you put in. We are approaching a linear regime. And that means that modulo sort of massive breakthroughs in AI, we are starting to see, I think, the contours of the limits of the tooling. And we need to start understanding those and working with them. And so throw it all in their Claude and see what comes out is almost never going to work for these complex physical systems. We need to think about them harder. So for A3, the point of forward deployed engineering is twofold. First, you will never solve these problems by tossing software over the wall because of the deep physical nature. Genshi Gumbutsu, we learned this for like 80 years. And then the second is that we don't want to solve one problem. We want to solve a whole class of problems. And that class of problems is a couple levels conceptually above where other people are focusing right now. That class of problems is automated root cause analysis. It is a problem in the factory. It is a problem in field service for hardware. It is a problem every time. I saw a billboard on the 101 of a guy leaning over his car with, the hood up and the smoke coming out, and it says ChatGPT. That is ChatGPT telling you, that is OpenAI telling you that root cause analysis is one of the major uses of AI. And that is what we are going after, is doing that at the enterprise level.
So if you are in advanced manufacturing today and you have lived through all these painful failures of ML and other technologies you describe, and you are now saying, this Matt guy, man, why now? I buy it. What's my first step? What would you do in their shoes?
I mean, I would step back for a second because the answer is usually they don't buy it. People say, I've heard this said by people, and this is again a case where status is really important. You go to somebody say, what, we would like to do an experiment. This, we were Toyota, and we were like, we'd like to do an experiment where we want to sort of try and solve some part of this problem using, some set of machine learning tools. People say to me, a guy says to me, I've heard this before from you guys, and everybody says it's going to be easy, and it never works out. And I say, I don't know who hurt you, but if anybody on my team told you this was going to be easy, I would slap the words out of their mouth. We do not know what we were doing. I had a pin on my bag that said, I have no idea what I'm doing, because nobody has an idea what they're doing. These are extraordinarily complex problems that do not have one size fits all solutions. And so the very first thing to do is to admit that people have been burned before, that the things that have come before have not worked, and that you are going to try to give them something new using their input and doing it a lean software way. Another problem that you see at large organizations is that sort of the IT groups, again, you coming into sort of the conflict between IT groups and manufacturing groups that arises out of sort of these different cultures and different ways of thinking and different decision-making processes, which is the subject of my book, that the IT group often goes off and does a thing and comes back 18 months later and they hand it to people and they always solve your problem. And you say, actually, no, you didn't. You didn't solve anybody's problem. You didn't bother to find out what my problem is because they don't understand manufacturing. And it is a very different field of endeavor. So the absolute first, second, and third thing you have to do, what a forward deployed engineer has to do, is you have to go listen. You have to go listen very hard. You have to listen carefully. And you have to not push your ideas on people. You have to be like any sort of product development and sort of product discovery, you have to really think about how to interpret what people are telling you and fit it into a process where you can help them as opposed to simply sort of tossing something over the wall.
I love it. I love it. Go see for yourself. Matt, people who want to know more about you, how do they find you?
Our website is a3analytics.ai. A lot of information there. And I'm pretty easy to find on LinkedIn. I've done some writing on LinkedIn. My LinkedIn handle, as well as my personal website, is drmattyg, drmattyg.com is my personal handle, and my Blue Sky and my Twitter. And, I think the work at A3 Analytics is an ongoing process of us discovering how to use these AI tools for these processes. And I'm really excited about it. And we're doing some amazing stuff. And then some of the writing that's highlighted both on my personal website and on LinkedIn gets more into the details of these ideas like holistic versus analytic thinking and how those inform our approach.
Yeah. As somebody who was trying to learn about how your Palantir past informed your present day views and sank my teeth into those writings, I can recommend our listeners go have a look. It's good stuff, informed by real pain, real experience. Matt, thank you so much for your time. Thanks for being on the podcast.
Hey, thanks, Henrik. It's really great to talk to you.
Yeah, awesome.